Hello, everyone. I'm Anssi Söderena. I'm a senior software developer at Fusion Layer. Greetings from Finland to everyone. And Fusion Layer is a company specialized in IPAM technologies, so like bookkeeping for IP addresses. And also we do DHCP appliances, DNS appliances, and now SZTP. So, can you hear me still? Yep. Okay, so I'm here to talk to you about service deployment using SZTP. So, but first I will tell you a bit about the SZTP in general, about the challenges and open questions that we still have. Of course, this comes from like a just a developer's perspective, what challenges we have been facing and what questions are still open, how we could do them at all and how we could do them better. And lastly, I will show you an example how we can use SZTP to take onboarding to the next level and deploy a service using it. So before we get to the main course, just briefly go over what the SZTP is. So the idea is that you order a new device, server or a DPU, IPU, whatever. You ship it to the address where you want to deploy it. And then you have the option to maybe travel there yourself or pre-install it before shipping. But how about you just have somebody press the power button and the device will automatically onboard itself. The device comes up with the correct boot image, applies day zero configuration, and the configuration scripts are run, which handle everything the configuration may be left undone. And with SZTP, that's possible. And it sounds good, right? So although it seems like magic, behind it all is still an SZTP server and an SZTP client. So the easy part is that you can put the server anywhere where the client can connect to. But the challenge number one is to how do we get the SZTP client to the device before actually booting it up, making it actually zero touch. And options are maybe the manufacturer includes the client in the base image, or we use network boot or some platforms auto provisioning tools like Cloud Init. But of course, the future goal would be to have the SZTP client included by default in a standard OS images, for example. Like why should we limit ourselves like to only onboard DPUs, IPUs, even though they are the main goal for the OPI for now? But basically, why couldn't you onboard a normal server also, or maybe even a virtual machine? And we actually have. So briefly, from the server we are serving to the client, we are serving conveyed information, which holds all the important bootstrapping data and owner certificate. It's like your public key to the device users. Your public key the device uses to check that the bootstrapping data was really signed by you and not anyone else. And ownership voucher, like a signed receipt from the manufacturer saying that the device belongs to you. So in conveyed information, you can serve a boot image used for DPUs and appliances, which the device downloads, verifies, and reboots into. Then we have the pre-configuration script. We have the configuration file applied, and the post-configuration script runs. And just to clarify that the configuration file isn't a script, it's like a vendor-specific day zero configuration that the device applies to set up the essentials. So what I like about the SZTP is just not like what I like about the SZTP, it's not just for one vendor or for one operating system. We can use the same standard to onboard servers, DPUs, and other network devices. So just a quick example of a SZTP workflow. So the device boots, the SZTP client starts, and the client collects information on the device, like the serial number that will be used in various authentication tasks. Then we discover the bootstrapping server. The client can read it from a DHCP option, from DNS, or from removable media. And then we connect to the server via RESTconf over HTTPS. And then we fetch the conveyed information, which we talked about in the last slide. And if we are given any redirect information, we will follow it to the bootstrapping server. And then to the main part, we download, verify, and install the boot image and reboot. And then the pre-configuration script runs. We apply the configuration and run the post configuration script. And we report the progress at each step to the server. So something about the current status of the SZTP client. We have the OPI's SZTP client, but also we at Fusion Layer have tried our hand in developing one. As Fusion Layer has become a member of the OPI, we are happy to look into merging the clients together in the near future. And I would like to highlight a couple of things from this list. So, of course, some of the challenges are like platform specific, like, for example, the DHCP discovery of the SZTP bootstrap server. So rather than reading it from a device's lease file, we try to actually include a DHCP client in the SZTP client to get like the most real-time data from the DHCP reply, and therefore discover the actual bootstrapping server. And here we actually run into like an issue like that this only works for Linux, for example. So you might have to wait for before we get to onboarding your Mac servers. But yeah, this is like just an example of many when we try to make the client universal, but we are now, of course, focusing on the most used operating system and architectures. Also, one of the major questions here is that what do we do about the boot image? Like about the boot image, now it mostly concerns like DPUs, IPUs at this stage, but in the future, maybe some other devices as well. But I don't think there is any like universal way of doing this. Like the OPI lab repo, for example, has a section about updating the firmware, but it's just marked as a to-do for later. But like I'm just thinking this from an SZTP client developer's perspective, that we actually need some universal way to tell the client to update the boot image, like verify it and reboot the system. And I think the same goes for the applying the configuration file. The device can handle it, I guess, in its own way, but we are still missing some universal command to actually apply it. And now to the fun part, actually. The standard, actually, the RFC standard doesn't mandate the script language. And we have been using SH and Bash because they are near universal on Unix-like systems. But however, the language could be anything that the device and the client support. So here we are finally dipping into our topic today. And instead of like using the SZTP to set up initial use of maybe SSH keys or something like that, and networking, why stop there, as we can like set up the services from start to finish with SZTP. So here we can see a really simple setup that can be run via SZTP, but of course you can write as complex as you want. Okay, so I have a small demo for you about the onboarding service using the SZTP. I wasn't too sure about the connection from here to the lab, so I took a liberty to film the demo beforehand. So any SZTP server will do as long as it follows the SZTP RFC. The screenshot you are looking at is part of Fusion Layer's own proprietary SZTP server solution, but which I'm using for this demonstration to show you what an SZTP server UI could look like, and maybe even change the way you look at SZTP as what it can do. The idea here is that using the UI, we can add a new device, we can pick a service from the catalog, it will create a pre and post configuration scripts, which we can still modify before activating the device, thus allowing the SZTP client to connect to the server. So it's a small video, but so here we are selecting the service that we want to set up while onboarding the device with SZTP. The device in question is a server running Ubuntu. And here our server automatically generates the necessary default configuration scripts for installing the service. I'll press play. Okay, so the scripts are actually written as Bash. The required commands here are quite simple to actually onboard it. So using the package manager app to upgrade the system packages and then install Nginx. But you can build more complex scripts when needed. And we can modify the scripts even before activating the device. And I just deleted some unnecessary lines that we don't need here. So as I'm now activating the device, the SZTP server sets the device ready for connections, and the UI displays that we are waiting for the client to connect. And next up, I will start the SZTP client on the target device to start the discovery and the connection. And already we can see the SZTP server receiving reports from the client. We are waiting for it to upgrade the system packages and then installing the Nginx. And now, as the client reported the configuration script output back to us, we can view it from our logs. I know the text is small, but it shows the package manager output, and lastly, the service status for Nginx. And so this all comes from the client. And now let's verify that the service actually installed and is up and running. Just a moment. It seems to be up and running. And now let's check that the device IP address and verify that the Nginx actually answers. Yeah, and it seems to be successfully onboarded as we wanted. Yeah. So just a quick note that usually onboarding is referring to the day 0 configuration, while the day 1 configuration is usually done by other orchestration tools or even manually. while using the SZTP for day one configuration straight away to set up services is handy. The configuration script need to be tested before they are deployed. We could, for example, spin up a virtual machine with the similar specs and OS to run the configuration script to verify that the services are up as planned for activating the target device in the SZTP server. So overall, we will still have work to do with the SZTP, but the solutions and flexibility it offers already at this point cannot be denied. I personally see that the SZTP does have an important role to play in the future. So thank you.
There we go. Couple questions. I know that we can use SZTP to get the initial IP address on the card, so we can address it and all that good stuff. But we need the SZTP client on all of the cards. Do you know which ones already have that client baked in? Which cards have that baked in? I know OPI, one of the things that OPI I think was successful in was convincing the vendors to get a Redfish client installed on all the cards. And I know we've talked about getting SZTP client installed on all the cards. Do you know which ones have done that already?
Sorry, I can't really remember. I think, well, at least in the like pre-baked, I don't think any of those have.
Okay. VJ, do you know if is the SZTP client on the Marvell CN106? Is that baked into the base firmware, the SZTP client? Yeah, I can't. So I know I've done demos where we've shown each of the cards once it had a client on there doing all this work. I just don't remember which cards have the client on there and which ones don't. Swati, do you know? On the IPU? It's there, but don't use it. Okay. So it sounds like that's an area we need to work on, is getting the vendors to work with you all to get a workflow figured out there, like especially that ownership certificate work. What do you call ownership? Voucher.
Yeah.
Get that voucher on there, and in a standard way. I'm excited for what you guys are doing here, because it is a difficult thing. Like you said, you ship a card and then you call the lab manager to go figure out what the IP address is once it comes up in DHCP, and you go through this. It's a manual process, and that's the goal of SZTP, is to not make it manual, and I like that. But
yeah, especially like for example, when talking about non-DPU, for example, so we still have the question about the SZTP uses certificates to verify and secure the connection. Like if we want to onboard some other device than DPU, how do we get the search there? Do we need to do that manually, or is there a better way? But yeah, but one of the major questions here is that the boot image, how do we do that, like universally on all DPUs and devices? Thank you.
I had a question.
Sure.
Is your software open, or?
The client, SZTP client is open, and it's under Apache license. But the SZTP server, it's a proprietary product of FusionLayer. Yeah, exactly. Yeah, so sorry. Exactly. The SZTP server is not on the card, so only the client. And it doesn't really matter like which SZTP server you're running as long as it's like the RFC compliant. Yeah. Thank you.
Thanks a lot. Thanks a lot, Ansi. Is there? So there is a comment that says, just a second, let me check. Oh, the initial portion of this ZTP approach looks similar to FIDO specification for device on board NIS TIR 8259D. Have you looked into it?
Well, sounds familiar, but mostly I have just looked into the SZTP RFC and not FIDO, but I will check it out for sure.
Thanks. Okay. Thank you. Thanks a lot, Ansi.